All right, we're going to go ahead and get started. I'd like to thank everyone for attending today's webinar. My name is Theron Tobalski. I'm with the Illinois Ready Mix Concrete Association. I'm the Assistant Executive Director. Part of my job is to promote concrete and to educate people on all the different types of concrete that are out there. This will be the first of 12 webinars in our promotion webinar series. A couple things we need to go over today. We will be following the IRMCA antitrust policy. We will make sure that we are not discussing any specific pricing or trying to set market pricing with the people who are attending this webinar. If you feel that we are in violation of the antitrust statement, we are encouraging you to please get off the webinar, say something in the chat box, and a full copy of the IRMCA antitrust policy is on the IRMCA website on the webinars tab. So if you'd like to review it, see what it is and make sure we're following it, you could go to the website and see it. This webinar will be recorded. We intend to put the webinar on the IRMCA website on the webinars tab. So you'll be able to go back there and review the webinar in case there was something you want to look at and go over. One of the reasons why we're hosting these webinars is as we put a promotion plan together with the engineering community, we had 3 asks that we'd like to ask the engineering community to do. One is to put a concrete and a asphalt pavement design on every industrial warehouse manufacturing project that you're working on. We want the 2 industries to compete for those parking lots. The second ask is to make sure that the concrete and asphalt designs are apples to apples. We want to make sure that you're picking a load that you're going to be designing for and making sure that each pavement is designed to carry the same loads. The third thing that we'd like the engineering community to do is make sure that you're discussing maintenance plans, a 20-year maintenance plans with the client that you are designing your pavements for. All that information should be part of the owner's decision. And that's what this webinar and the second webinar will help cover. It'll be an education on how to design concrete parking lots, how to design asphalt parking lots, and how to look at maintenance costs over a 20-year period. For more information on these webinars, you could go to www.irmca.org. There will be a webinars tab to click on. When you click on the webinars tab, it'll list all 12 webinars. There will be a read more option. That option will allow you to see more details specifically on what that webinar will cover. There will also be a register and sponsor option. We will open registration 2 days after the previous webinar. So this Friday, you will be able to register for the next webinar. As we mentioned, we will be recording this webinar, and on each individual webinar page, we will post the recorded webinar. On each individual webinar page, we will also be showing our sponsors. As you look here is a list of all the people who have sponsored today's webinar. And when you go to the website and click on the individual webinar, it'll show these sponsors, and they will have up to 3 links that they want to share with you. These links will have products that can be specified in concrete. It'll be different applications for concrete. It'll be environmental impacts when you use concrete and more. So this will be a great source of information for you to find different information that's relevant when designing concrete. Next, I'd like to introduce Luke McHugh. He is a PE and Senior Director with the National Ready Mix Concrete Association. He has over 30 years experience providing consulting, engineering, and construction support services on a variety of airport and site development projects. He earned a bachelor's degree in civil engineering from Drexel University in 1987 and a master's degree in engineering management from Drexel University in 2005. He is a registered professional engineer in Pennsylvania, New Jersey, Delaware, Maryland, and Florida. In his role at NRMCA, he is responsible for working with NRMCA partners and members to help deliver successful local concrete paving projects and implementing strategies that increase the use of various forms of concrete, in parking lots, local streets, and roads, and other applications. With that, I'll pass it over to Luke.
Okay, thank you, Theron. I'm gonna bring up my presentation now. Okay, can everyone see that okay?
Yep.
Okay, welcome everyone. As Theron said, I'm Senior Director of Local Paving with the National Ready Mix Concrete Association. And today we're going to talk about how to design concrete parking lots using ACI 330. A little bit about NRMCA. We are a national trade association established in 1930, so we're 91 years old. Our headquarters is in Alexandria, Virginia. We have 1,400 or so member and associate member companies, and we represent about 75% of the ready mix producers in North America. So our mission is to really serve the industry through compliance and operations, engineering and testing, governmental affairs, and then local paving, which is where I come in. And then we also have a structures and sustainability group called Build with Strength that is focused on concrete buildings. So we do buildings and paving. Little disclaimer about the presentation. It's really prepared for your information only. It's intended to be used by professionals, and it is up to you to take this information and to incorporate that into your designs as you see fit. The material here is also copyrighted unless we say otherwise. So if you look at the two pictures on the screen, you can see that there's 6 inches of concrete and then 6 inches of asphalt and stone or flexible pavement. And so really what we're going to get into today is that, you know, these two really are not equivalent pavement sections. You have a rigid pavement section and a flexible pavement section. We'll get into how those two pavements work from a design and also construction standpoint. So couple interesting quotes with under designing pavements. The first one is from Cornell's Dr. David Orr, where he says, under designing roads can mean more expensive repairs for local towns and counties in the long run. And then also from the Rutgers Center of Advanced Infrastructure and Transportation, when an agency does not prepare a specific pavement design, what ends up getting built is oftentimes underbuilt. While they might have saved some money at the time of building, the cost comes back to bite when the road then needs to be rebuilt earlier than expected. I like to show this picture because I actually, though I cover, I'll say the Northeast part of the country, I tend to see this in Illinois more frequently than anywhere else. And really it comes down to the asphalt pavement being underdesigned and you've got depressions in the pavement. So what do engineers typically use to design concrete pavements? And here's some of the common answers we hear. Nothing. We only design asphalt pavements, or we use what we've always used. Whatever the geotechnical engineer recommends. Sometimes if it works for the DOT, it's good for me. Some engineers will use the Ashtow design guide, which originally in '72 and has had 2 major revisions in '86 and '93. Or in Illinois, they'll like to default to the IDOT Pavement Design Manual. So let's take a look at that for a second, the IDOT Pavement Design Manual. So I know we've got engineers and folks from around different parts of the country, but I'll say probably the lion's share are in Illinois. And so IDOT has Chapter 54, their Pavement Design Manual, which I'm sure many of the engineers in Illinois are familiar with that. So if you look at that chapter, this is the first page, and you go about 2/3 of the way down the page, and you'll see a paragraph. It says, the pavement design procedures outlined in this chapter are for pavements on the state system only. The procedures in this chapter are inappropriate for non-state agency pavements or parking lots. So, why anyone would use this chapter to design parking lots with this disclaimer, I really don't know. So you really shouldn't be using that. Further on in the document, it talks about the mechanistic and modified Ashtow approaches. So here what it says about the mechanistic approach is the procedures are applicable to jointed plain concrete pavement designs with nominal 15-foot panels. Well, we're going to see within our design procedures here with ACI 330 that we could have panels less than 15 feet. And then, so this is not a design that you want to move forward with either. Looking at the modified Ashtow references, okay? The modified Ashtow design procedure are based on the Ashtow road test pavement performance equations. They correlate to test sections with pavement design, the magnitude and configuration of the axle load, and the number of axle applications. And it also says what, what that's based on. So let's take a little bit further deep dive into the Ashtow design guide and a little bit of history here. So really much of what we know about Ashtow is that the equations were developed from physical road tests. So at the time, the federal government, in advance of the interstate highway system, developed test tracks out in the middle of the fields in Ottawa, Illinois. And they ran trucks 24 hours a day, 7 days a week, just to gather data on how different pavement sections would function. So they included 368 concrete sections, 468 asphalt sections, and the focus was mainly on highway pavement. Here's just a sample of what that test loop looked like and the types of trucks going back to the late 50s and early 60s. So at the time, engineers really didn't know what thickness section they wanted to design to. So basically they guessed, and they came up with various flexible pavement sections that had varying thicknesses between the asphalt surface section, the base thickness, and the sub-base thickness that ranged anywhere from about 15 inches total thickness to up close to 25 inches. Likewise, with the concrete sections, they guessed with thicknesses there as well. You'll see that mainly those thicknesses were in about the 10-inch range or close to it. Most of them had a fairly thick sub-base course as well. And one concrete section was placed directly onto the subgrade. So what they did when they collected all this data, if you look at the graph on the left, they found that you start with a certain level of acceptability, and over time, along with time and the load repetitions, you start to decrease in your service level that you're able to provide. If you look at the graph on the right, this is basically the data that they collected. And what they found was interesting, and that the asphalt sections, they were able to test them to failure. And when you're designing, you're looking to identify long-term performance like this, you want to get these sections and test them all the way to failure. What they found with the concrete sections was that only about 25% of the concrete sections were they able to take all the way to failure. So they really didn't know at the time what the long-term performance of concrete was. They just knew that the sections that they picked were probably going to be sufficient over a long period of time. So let's take a look at this, and I apologize if I'm going over some information that some of you already know, but the way the two pavements function are completely different. We know from the flexible pavements, the asphalt pavements, it's a combination of how all the combining layers of the pavement work in concert with one another to support a vertical load. So when that load is applied to the asphalt pavement, it is directed through all of the pavement layers down to the subgrade via point load. When you look at the concrete section, the stresses or the load is mainly handled within the concrete section itself. So it's the flex of the concrete or the flexural strength of the concrete that support the load. There's very little support value that you get from the either subgrade or also any type of base material. So we'll take a look at this as we go through this a little bit later on. But so if you look at your flexible pavement section, here's a typical section where you've got a surface course, a base course, and a sub-base course. And we have our typical coefficients with various structural numbers. So if you take the structural number by the thickness and you come up with a number, and then you add those up for each one of the sections, you get a structural number, and then you equate that to what the anticipated load is going to be over the life of that pavement. And you want your flexible pavement section to be greater than what that anticipated load is going to be from a traffic standpoint. So all the testing that was put together, this is the equation that was ultimately derived from that Ashtow testing. So if you can see the equation itself is fairly complex. You're looking at traffic, you're looking at a standard deviation, what's the serviceability, what's your pavement thickness, what's your modulus of rupture, your drainage coefficient, load transfer. We're going to talk about that in a little bit more detail, and then the modulus of your subgrade. So there's a lot of information that goes into this equation, and I can certainly understand why designers shy away from concrete design. It doesn't have to be this difficult, and we're going to go through that today. So basically what they found from the Ashtow road test was that the transverse joints were all doweled, and they were all at the same spacing. So they had jointed plate concrete pavement, and they had dowels placed at either 15 feet, or jointed reinforced concrete pavement, they had dowels at 40 feet. The Ashtow equation does not address joint spacing. So if you use that equation, you're going to end up with a 15-foot joint spacing. The pavement design equation is also very sensitive to the joint load transfer coefficient, which was that J factor in the previous page. So if you're trying to use this equation for undowed pavements, They do have a conversion, but it's really a guess. And it's very a conservative extrapolation. So one way to improve load transfer and thinner pavements is to use either a shorter joint spacing. And that's really one of the main reasons why we encourage not using Ashtow 93. So what should engineers use to design concrete pavements for local roads or parking lots? ACI 325 and ACI 330. So what are they? I like to make this correlation, but anyone who works designing buildings or knows structural engineers that design buildings, I'm sure they're familiar with the American Concrete Institute and their code 318 for designing concrete structures. It's comprised, it's really different committees that are leading industry experts and engineers. And each one of these guides is really a complete and concise document for both design and construction. So ACI 325 is the design of streets or local roads. We have ACI 330, revision 08, which is the guide for concrete parking lots. And then there's also other guidance that's out there for the construction of concrete pavements as well, which is 325.9R. So just looking at the table of contents of what's in this document, it really is all encompassing. So there's a description in both the an introduction and scope, some definitions, the pavement design, materials, construction. It gets into its inspection and testing, maintenance and repair techniques. And then there's some appendices that gets into procedures for concrete pavement design. It talks a little about the subgrade and also gives details for examples. Mainly what we're going to focus on here today is going to be chapter 3, the pavement design. So if we look at the design of a typical concrete pavement, we're going to focus today on the thickness design, but other things that you should be concerned about would be smoothness or reliability, where your longitudinal joints are, your transverse joints, the texture of the surface, where you place tie bars, the subgrade, your subbase, the materials in your concrete, and also proper use of dowel bars, which are optional. Okay, so now let's go into looking at a pavement design using ACI 330. The pavement design is based upon the PCA design method and from the Portland Cement Association. And in that design method, there's really only 2 failure methods that we're concerned about within those pavements. There's a fatigue failure, which is due to the slab flexure or bending, and then the erosion, which is really joint erosion. So it's as the load moves across the pavement, you've got bending at the pavement edge before it gets to the edge of the next pavement. And what we find is that those edge loads produce the worst stresses. So that's a fatigue-based tensile strength due to edge loads. And the corner loads produce the worst deflections. And that's where we get our highest stresses due to erosion. So really looking at 2 failure modes here that are going to affect the pavement. Kind of simplifies things. Some key terminology that we're going to look at today is our K, which is our modulus of subgrade, which a K is similar to a spring constant. We're going to look at average daily truck traffic and also the modulus of rupture of our pavement, or essentially the flexural strength. So this is table 3.1 out of ACI 330. And So basically what it tells you is based upon your soil type, it equates what an equivalent K value would be to a similar CBR or California bearing ratio. And if you look, you can have poor soils, low support, from a 75 to 120, and correlates to a CBR of 2.5 to 3.5. So we'll talk a little bit more about those as we get through this. But those are the numbers that we're really going to be interested in right there. Table 3.2 in ACI 330 is the modulus of subgrade reaction. And really what this table shows you is if you look down the left-hand side, we have our subgrade value K. And then as you go across the top of the table, it has various subbase thicknesses, 4, 6, 9, and 12. And then we have different types of base courses that we could place underneath our pavement, either an aggregate subbase, a cement treated subbase, or some other type of strengthened subbase layer. So, but what we're going to focus on is right here, because this is fairly typical of what you're going to see in most areas, or at least most projects that I've been working on with Theron, is that we're going to have an area that has a poor subgrade. So we're going to say it has a K value of 100. And I want to point out, by adding in that base course, what that does to your effective subgrade reaction. So by putting in a 4-inch base course, you strengthen that a little bit. By adding 2 more inches, you really don't get that much more value out of putting that additional aggregate layer. And we'll see how that affects the pavement thickness. So it's really more important that your base be more uniform than having a very strong base that you would need for a flexible pavement. We're also going to look at the average daily truck traffic. In ACI, they categorize them A, B, C, and D. A is cars. D is really your semi-trailers. So we'll get and take a look at that as it gets into our design. So we've got our modulus of rupture or flexural strength. When we're looking at our concrete strength, you're really looking at a flexural strength that's about 600 PSI, which equates to 4,000 PSI compressive. So we go into, this is table 3.4 in ACI 330. And let's run through an example here. So we're gonna look at our thickness design based on our soil support. So we're gonna pick a K value of 100, which is equivalent to a CBR of 3, typical for silty clays, fine-grained pavement. So it's a CBR of 3. We're gonna pick our concrete strength. And here it gives you options from 650 flexural strength down to 500. And that's for each of the categories. Now we're going to choose our average daily truck traffic. In this example, you can see down the right-hand side in the manual, they give samples of various traffic categories and the number of trucks that you can expect with that type of traffic category. So if we assume we have a K value of 100, and we're going to use 4,000 PSI concrete, and we're going to have a traffic category A, which would be typically cars and light trucks with the occasional truck, 1 truck a day. We end up with our recommended thickness is 4.5 inches. 4.5 inches of concrete. So if we take a look at what does that mean. So if you look at pavement section 2 on the bottom of this page, we have a 4.5-inch concrete pavement. We have a 4-inch aggregate base course. And what I've done here is, assuming that all else is equal with traffic in our subgrade, what that equivalent asphalt or flexible pavement section is for various aggregate bases. So we've got what that would be for a 12-inch aggregate base, a 10-inch aggregate base, and an 8-inch aggregate base. So what I like about this visual is that you can see that the concrete section is going to be significantly reduced from the other three. And keep that in mind when you're building up that or excavating down to subgrade. This is less excavation that you would need on your project. Here's a typical project or case study. This was a Lowe's home improvement project. So on the plans, they had an asphalt pavement section for a standard and heavy duty section. They had an equivalent or concrete pavement section, which was 6-on-6 and 8-on-6. When we reevaluated that based upon ACI 330, that 6-on-6 was 4.5 inches directly on subgrade, and that 8 inches on a 6-inch stone base was 6 inches of concrete on a 4-inch stone base. By revising those pavement sections, the cost savings to the owner was somewhere in the neighborhood of 6 figures. So definitely worth it to the owner. Wanted to just bring this also to your attention. There are some guide specifications. NRMCA has put together several design guide or specification guides to help you with specifications. ACI also has a standard for unreinforced concrete parking lot pavements and site paving. What's nice about these documents is that they're all encompassing. I know a lot of state engineers like to default to using standard DOT specs, and anyone who has worked with DOT specs knows that they reference sections in other parts of the document, and trying to correlate all those sections and get them in your specifications can be somewhat cumbersome. So this really has everything you need all in one place, from your materials to your construction and execution. So we went through a design using ACI 330. I'm going to go through an example here. I'm going to pick a street design using a program called pavementdesigner.org. Pavementdesigner.org is a design program for designing concrete pavements that is a collaboration between the Portland Cement Association, the American Concrete Pavement Association, and NRMCA, the National Ready Mix Concrete Association. So those three organizations got together and developed one design program that is free to anyone to use, and it's available on the web. So if you type in pavementdesigner.org, this is available to everyone here. So a little bit more about Pavement Designer. It is based upon ACI 330, what we just went through, and ACI 325 for roads. So I'm going to run through an example right now on pavementdesigner.org. When you first get into the program, this is what you will see. It will ask you to register and log in. You don't have to, but if you, and they don't collect information, but by logging in and registering, you can then save your designs, save your design for your for your project. So this is the first page that you'll see, and you're going to click on Start Designing. The next screen that pops up, you have the option for parking, street, and intermodal. Intermodal is when you get into those projects where you have forklifts, container handlers, very large vehicles that are not over-the-road vehicles. So they don't have the same stresses and they have different tire configurations than you would see on a typical street and parking lot. So we're going to run through the street module. It's the same as the parking lot, but so if you do street instead of a parking lot, you'll still come up with the same answers at the end. So we're going to click on here. It gives you the option for an overlay. That's a concrete overlay on either asphalt or concrete, a concrete section or a composite section where you can have concrete and asphalt together. So we're going to look at just the concrete section. The next page that comes up, you'll see that it says at the top of the page, project level, pavement structure, and summary. Those are the only 3 pages that we're going to get into. You can't get into the next page until you populate all the information here. So again, we're going to go through the street module. And so we're going to look at traffic. Here I've chosen a residential traffic spectrum. And you'll see over on the right-hand side, the traffic summary details. It shows you what your truck distribution is for that particular traffic spectrum. So this is a residential area. It shows a 20-year design life. I said I'm going to have 5 trucks per day. I anticipated a traffic growth rate of 1, directional distribution of 50%, and a design lane distribution of 100%. So basically what that tells me is I've got a 2-lane local road and my traffic's evenly split 50-50 going down that road. The next column over, we're going to look at reliability and percentage of slabs cracked. Now, typical for a parking lot and even a local road, we'd use 85% reliability and 15% slabs cracked at the end of the design life. You can change those values. They may or may not affect what the ultimate thickness is for your pavement. The program will calculate what your number of trucks you have in a day, and also what the total trucks in the design lane is over the design life. So we've gone through the traffic spectrum. We're going to come down here and click on pavement structure and get to the next screen. It gives you the option of jointed plain concrete pavement, roller compacted concrete pavement, or continuously reinforced concrete pavement. But today we're going to focus our attention on jointed plain concrete pavements. So you click on there. In the parking lot module, it does not give you that option. So if you wanted to use roller compacted concrete pavement in a parking lot, like I said, you could just come over to the street module and design that. So now we're going to look at our subgrade. So here, the input value I have is CBR. If you know what your modulus of subgrade reaction is, you can put that in, or if you put in the CBR, it'll calculate that for you. We come over here to our concrete. You can also choose, the options are 28-day flexural strength, your compressive strength, your modulus elasticity, or your split tensile strength that you can put in here. But I chose the 28-day flexural strength of 650 PSI. You'll see that there's options there. Do you want microfibers in concrete? You can put that in yes or no. I chose no. And edge support, I chose yes. So typically on a parking lot, if it's curved, or even if it's not curved, I still choose yes as an edge support. Remember, this is a street module, so really no edge support would be an unsupported edge on a traffic lane. We're going to put in our sub-base layers here. I chose 1, and my sub-base is going to be 4 inches of a granular base. I put that in there. And then also, these are the different options that you have for that choice, but I chose a granular base. And then you can click onto the design summary. I'm just gonna back up a little, see if it'll let me here. Yes, so you'll see that there's a blue dot on the right-hand side of the page, and you'll see that I modified the K value there. And that is because I wanted to use the ACI 330 criteria. The criteria that's in the program is really an ACPA highway pavement criteria that is slightly different from ACI 330. So, and we're a little bit more conservative with the lower value. So we're going to get to our design summary, and you'll see here that this is your output. So it gives you both a doweled and undoweled output. We are going to focus on undoweled, and I'll talk about that in a little bit more. But then also there's some sensitivity graphs that you can click on. So the K value, the flexural strength, the design life. So if you click onto those boxes, it will show you if you change the flexural strength, how will that affect your pavement thickness? If you change the design life, how will that affect your pavement thickness? So you don't have to go through the design each and every time to see if that's going to change your pavement thickness. So here we have an undoweled thickness of 4.75. We would round up to the nearest ½ inch. So our design section would be 5 inches. And the typical spacing, maximum spacing, would be 11 feet. Now, remember that Ashtow 93 equation? The joint spacing was 15 feet. So if you work it backwards, your joint spacing and your pavement thickness are related to one another. So if you have a 15-foot joint spacing, you're going to have to make your pavement thicker in order to adhere to that criteria. So you can see from this standpoint, we've got a 5-inch section with 11-foot joint spacing. Now, if you click on Generate Report, this is what you'll see. You can input the project name. It gives you your design summary that we had on the previous page, your pavement structure, your concrete information, your traffic information. So if you have this output, everything that you have here, if you have to go back and recreate that design, you've got that ability to do that. Plus now you've got your design output. So some information that is also in the pavementdesigner.org program and webpage. So I encourage you to take a look at that as well. Real brief, I want to just give you this correlation on concrete pavement thickness. So here I put a table together where I assume a 20-year design life, 85% reliability, 15% slabs cracked at the end of the design life, no dowels, and no industrial vehicles, no forklifts, no container handlers. So I've got a CBR of 3, which is with a 4-inch aggregate base. That's a K of 130. And I use category D semi-trailers with a 600 PSI concrete strength. So if you look at this, look at the column on the left and the center column. You can see with 55 trucks, it equates to a 6-inch thick concrete section. If I increase my pavement section by ½ inch to 6.5, I more than double my traffic capacity. If I increase it by another ½ inch, I more than double it again, or 4 times what that was for the 6-inch pavement. It's actually 5 times. So what I wanted to point out here was by adding a ½ inch of pavement, you can significantly increase or decrease what your structural capacity of your pavement is. You can't do that with a flexible asphalt pavement. You can't add ½ inch of material of asphalt and double your traffic capacity. So, and you can see when you get up to an 8-inch pavement, you're really up to about 2,000 vehicles per day on that particular pavement. If I look at ACI's position on subgrade, as I said, it's more important to have a well-prepared uniform subgrade than it is to have a high-quality subgrade. We want it to be dense, firm, and uniform. And I like to put down a 4-inch granular aggregate base, even though the pavement may not warrant it. It does give you a nice working platform. There's some areas around the country, they forego putting down any aggregate base as well. Now, do you need an aggregate base layer? If you want a construction platform, if you have very poor subgrade, heavy truck traffic, or you've got pumping that you might see within your subgrade. Some questions here. Do you need steel in your mat? And the answer is no. As Theron said in the intro, I come out of the airport consulting world. So I wanted to just show you, these are runway pavements at Denver International, JFK International in New York, and ORD is O'Hare in Chicago. Now, what you'll see is that there are dowels that they have in the longitudinal joints and then also the transverse joints for load transfer. But even more so, the FAA is getting away from dowels, having that in all the transverse joints except for being at the end of the runway. But there is no steel in the mat whatsoever. Some people like to put welded wire fabric, and they call it reinforcement, but it's not reinforcement. One, it does not make the concrete stronger. It does not stop the concrete from cracking. All it does is hold the concrete together when it cracks. And that's if it's properly installed. You want to install the welded wire fabric probably just about 2 inches below the surface of the pavement. Actually, you want to be a little bit below that because you don't want the saw cuts. You want to avoid that with your saw cuts. How many times have you seen this? So the welded wire fabric isn't doing much for you here if it's at the bottom of your section, or if you've got guys walking on it, it's not going to be in that top section of the pavement. So you've designed welded wire fabric, you've paid for welded wire fabric, but you're not getting what you paid for here. There's a better way, and we're seeing this more and more, and that's to add fibers. And when I talk about adding fibers, I'm talking about macro fibers, not the microfibers. The microfibers are really for plastic shrinkage, crack control. They're real fine. They're very hair-like. The macro fibers are a little coarser. They're probably about 1.5 to 2 inches in length. There's also steel fibers, but they're more for warehouse floors and not for parking lots. But you look at those macro fibers, they get placed into the mix by the ready mix producer, and they will function better than putting in any type of welded wire fabric. We talk about jointing. The object of jointing is really to, concrete's going to crack. And by putting in the joints, you want to tell it where to crack. It's there to accommodate normal slab movement, provide load transfer through aggregate interlock, and it gives you a nice look for your pavement. If we look at recommended spacing of the joints out of ACI 330, you'll see here when you get up into that 6, 7, 8-inch range, that's where your maximum pavement thicknesses or joint spacings up around 15 feet. Get down in the 4-inch range, you want to be in that 8 to 10 foot range. Some typical joints, we've got control joints. So those are the joints that are saw cut, which then create a weakened plane and allow the concrete to crack below the saw cut and help provide aggregate interlock. We have construction joints. So if you're paving forms, this would be where you strip the form and now you've got a vertical face. So you've got a two vertical faces that abut one another as a construction joint. And then we have isolation joints. If you have any type of structure, building, manhole, light pole, you want to isolate that from your pavement and the movement of your pavement. So those are isolation joints. Some people like to call them expansion joints, but they're not expansion joints. For load transfer for pavements less than 7 inches, we're looking for aggregate interlock. In some cases, you'll see this old detail with keyways. Stay away from keyways. It's an old detail and really causes more problems than it's worth. For load transfer on pavements greater than 7 inches, we have round dowels, plate dowels. We can also have tie bars, but they've got their place to hold pavements together, especially on longitudinal joints, but they are not used for load transfer. The question is, do I seal or don't I seal? You want to seal. The purpose is really for sealing is you want to prevent water getting in the joint, and also any type of dirt and debris. Keeps the joint functioning properly. Most effective saw cut. Again, you want to create a weakened plane in that slab, so you want to be 1/4 to 1/3 down. So I think I went through this. This is it's the Lowe's Home Improvement. I went through this one. I just kept it in my presentation. I don't know why. So we're getting close to the end. So really looking at to do or not to do. So don't copy and paste pavement designs that have been used on other projects. Really each project is unique. Not all owners have the same number of trucks or have the same needs. So ask your client about, what's his traffic type and what's the design frequency for those loads. If you don't have a geotechnical report that tells you what the subgrade is, no problem. The USDA has a website, United States, it's that agricultural website. If you go on there, they will give you a full report on what the native soils are in the area. And based upon what they tell you, you can make an assumption on what your subgrade soil is. If you're still not sure, be conservative. Let's say you have a poor subgrade. If in the end you find out that your subgrade is better, remember what I said about thickness. It's not going to change that much. So by having an improved subgrade, what's the worst that can happen? You might reduce your pavement section by 1/2 inch. If you don't have traffic data, also no problem. Estimate. You saw from that one slide. You can be high or low with your traffic, and you're not going to be that far off with your pavement thickness. You're probably going to be within 1/2 inch. So you're probably right, and you can always change it. If you're still not sure, or if you want to, all else fails, do call Theron. So call him, text him, email him. Theron will be more than happy to help. For those of you who are on the call that might not be in the Illinois area or around the country, if you want, you can also call me direct, call or email me as well. I just wanted to say that, it's not all concrete all the time. You want to really, Theron talked about giving them a choice. There's Coke, there's Pepsi. If you specify concrete, you really get some competition because not only will now you have asphalt producers competing against each other, now they're competing against ready mix producers. So you might find that overall you'll get better estimates on your projects. So some key takeaways here just to wrap this up. Concrete has a place. And I hope we've kind of demonstrated that to you today. Especially when you get into those industrial warehouse pavements, where you're getting into thicker, flexible pavements that you could replace that with a thinner concrete pavement. And now that you don't have steel's a big cost when we get into our pavements. Concrete's durable. You know, I mean, it lasts. It's made to last with minimal maintenance, and if maintained properly, will provide service life for many years to come. So it can be cost effective if you don't put steel in the mat, if you design to an efficient thickness. I've seen where concrete pavements can go toe to toe with the cost for an asphalt pavement. And also, you probably realize that concrete pavement thickness design is now much easier than you thought it was just an hour ago. So again, if you have any questions, please contact Theron. Throwing this up there, that these are just some resources that are available to everyone. At the top of that list is Theron and myself. And I'll take this time now. We got a few minutes for questions, Theron.
Thanks, Luke. The first question that we have is, in Pavement Designer, are the FAQs or help for typical values if looking for guidance for each input?
There are some values that do have pull down menus and will provide guidance, but not all of them. So I would say just get into the program and take a look at what those pull down menus are. And again, if you have any questions, you can always call Theron.
Another question we got, Luke, is there a minimum amount of steel for temperature control? For example, welded wire fabric.
For temperature control, I'm just going to reiterate what I've said earlier, and that is that you don't need to put welded wire fabric into the pavement. If your joints are properly spaced, there's no need to put the fabric in, and it's a cost savings.
Okay. Are you able to manually input a thickness of section and get the max joint spacing output without going through the whole input?
Yes. So if you go to the document inside ACI 330, there is a table, and I showed that in the presentation, that if you have a certain thickness, it will give you what the it'll give you the corresponding joint spacing, maximum joint spacing recommended for that thickness.
How much reinforcement is needed in parking lots?
0.
Can you expand on that for a second?
You don't need any steel within the mat. If you get into thicker pavements, you may need dowels for load transfer. Or if you have thicker pavements and lots of trucks, to put in dowels at the construction joint. So if you've got two vertical faces side by side and there's no aggregate interlock, you want to provide that load transfer to prevent joint erosion. So you want to put in dowels. Anything within the mat itself, you don't require any steel. There's enough flexural strength in the concrete to serve your purpose.
All right, one last question, Luke. Is it better to go with unreinforced concrete pavement or fiber reinforced concrete pavement?
It really depends. It depends what you're looking to accomplish, and that is by putting in fibers. There are benefits to that. As I said, it will help with controlling cracks and the width of the cracks. So if your pavement will crack or micro hairline cracks, it'll help to hold the pavement together. There's also another benefit that in some cases, the fibers themselves have a residual strength that could also reduce the thickness of your design in your pavement. So that's something you have to consider in the design of your section.
All right, we got a couple more questions that popped up. We'll take one or two. Wouldn't welded wire fabric be a good item for a small, irregular shaped panel?
I would say if you were just going to have it in an irregular shaped panel, yes. But I know from my airport days, if we did have irregular shaped panels, that was a recommendation from the FAA to put in welded wire fabric. So from that standpoint, I would say it's probably not a bad idea, but you don't need it everywhere.
Okay. When you refer to undoweled concrete, do you mean no dowels along the control joint for load transfer between slabs?
In thinner sections, yes, you would not need dowels. You would not need dowels at the construction joint for thinner sections, but also at the construction joint where you're saw cutting the pavement, you would not need dowels either. There's enough load transfer that you gain from the aggregate interlock that dowels would not be required unless you get into a lot of, serious amount of trucks. We're talking, 300 trucks going through that pavement in a day. Yeah, then I'd put in dowels through there.
All right, one more question, Luke. Are there situations where higher strength concrete with a lower thickness is cost effective versus lower strength concrete in a greater thickness?
It really depends. I don't know what the increase in cost is from, if you're talking 600 PSI versus 650 PSI, that's kind of the range I'd want to stay in. I like 650 a little bit more, especially in the Illinois area, because it gets you a little bit better durability. There's probably not that much of a cost difference between the two, but I wouldn't look at 1000 PSI concrete or 1200 PSI concrete to shave off, an inch or an inch and a half off my concrete section.
Okay. Thank you, Luke, for answering these questions. I'm going to wrap it up in a minute. All right, I'd like to thank everybody for attending today's webinar. The next webinar will be on February 17th. It'll be how to design industrial and light duty asphalt pavements. There'll be two presenters on that webinar. One will be Mike Carroll with Applied Research Associates, and the other one will be Mike Ward of Rabine Paving. Registration for that webinar will open on February 5th. And one thing, as Luke mentioned, we wanted to talk to you about is whenever you're doing something in Illinois and you have a concrete question or you need help with a concrete design, whether it's regular concrete, pervious concrete, roller compacted, concrete overlays, cement slurry for soil stabilization or full reclamation, you should think IRMCA. I'm going to call Theron and we'll help you. We'll be the first person you call and we'll help you through it. And a lot what Luke and I do is is in the last 4 years, we've worked with people on over 520,000 cubic yards worth of parking lot designs. People call us and say, hey, I need some help. I'm not sure what to do here. Some people will say, hey, I've done all the design. Can you just do a peer review and help us out? And that's what we're here for. It's all free. And we're just an extra set of eyes to verify what you're thinking or to help you try something that you haven't done before. So don't hesitate to call. We're here to help you. We don't expect you to be the experts in all these different types of concrete pavements and designs. That's what Luke's here for, right, Luke? You're here to be the expert. So
absolutely,
we'll help you through with that. And last but not least, Irmka is new to social media. We just got on LinkedIn, Facebook, and Instagram. So if you're on any of those social media platforms, please don't hesitate to friend us, like us. We will share technical articles, new technologies that are out there, and just another way to interact. So again, thank you everybody for attending today. I hope you enjoyed the presentation. If there's something we missed, something more you want to know, my email's on the screen right now. Shoot me an email and we'll make sure that we get another presentation to help answer your questions. Thanks again. Appreciate your time and you attending.